remember I told y'all with these that there's always going to be one missing piece, only one. And the other missing piece, if it looks like there's more than one missing pieces, the other missing piece is your quote-unquote obvious. And I told you that with time you'll get some practice with how to tell what's obvious and what's not. So like for example, for number 1, I need these triangles to be congruent by side angle side. And I know that these sides right here are congruent to each other. Right? My quote-unquote obvious for this problem is that these angles right there are what? They're vertical. Okay? I've got intersecting lines, opposite angles. So those angles are vertical. So that's my angle. And then remember for side angle side, that the angle needs to be in between the two sides. So it would have to be sides WV and XV. Okay? I don't know anything about angle U and angle Z. So you have to know something in order to say that that's the angle or that's the side. Okay? I know that those are vertical, so those are going to be congruent. I don't know anything about U and Z, those angles. So I can't say that, oh, well, those angles have got to be congruent. Unless I was given that sides U, W, and Z, X were congruent. Okay, if I was given that, then my answer would have been angles U and Z. But I wasn't given that. I was only given that those sides are congruent. So that must mean that my obvious has to be those verticals. So look for things like that. Look for vertical angles. Look for reflexive property. Okay, look for those things. So going on to reflexive property, like for number 2, I know that QS is going to be congruent to itself. So that's my quote-unquote obvious. Because for both of those triangles, if I take them apart, QS is with both of them. So that's my quote-unquote obvious. So that means I would need QR and QY to be congruent in order for that to be side, side, side. So look for those obvious things. They're going to keep coming up. Reflexive property, vertical angles, bisectors, midpoints. They're going to come up over and over and over again. So look for those things. Those are your quote-unquote obvious. Okay? And then for number 3, side angle side, the same thing with reflexive property. If I take these triangles and break them apart, JK is going to be with both of them. So JK is my quote-unquote obvious. I need the angle that's in between those sides, so it's got to be that angle right there and right there. Okay? It can't be any other angle, because if I knew that this was congruent and I chose those angles, it wouldn't be side angle side. Because for side angle side, that angle must be in between the sides. If it's not in between the sides, then it's not side angle side. Okay? Are there any questions on 1 through 3? Also, when I'm going over homework, okay, that's your chance to ask questions. If there's something you're not understanding, something that's coming out of my mouth that's not making sense, this is your time to ask. And that's why I didn't want to do a bell ringer today, because I knew it's going to take some time to go over this. Yeah, Emily.
For 1 and 2, for the line, so for lines you only have 2 letters, and then for angles you have 3 letters?
Correct, yes. Lines, so line segments and lines are 2 letters. Angles are the only time you'll use 3 letters, correct. Good question. Yes, angles are the only time you use 3 letters. And hold on just a second, Milo. For, I think you asked about this on Friday. So she realized that these were the 2 angles I needed, but she said, can I just name that angle K? No, okay, because angle K is this entire thing. But I only want that top half. So that's why I would have to use the 3 letters RKJ. If I knew that this side and this side were congruent, and those were my 2 angles, then I could obviously say R and I. But because that K is not all of K, I've got to name it with 3 letters. Yes, Mila.
So I got the same answer, and then the unit is like but like I just have them like I did before. Like I got it as V8 equals W. Like, does that matter?
Flip. Okay. Yes and no. Okay. If you name this as VX, then this has to be named as VW, because you're starting with V. Okay. But order necessarily, that doesn't matter. Okay. So you need to have the letters in the same position. But if you have VX first and then VW here, I'm fine with that. That doesn't make a difference. Okay. Leave that alone. The angle must be in between the 2 sides. So like for example here, I know that those are vertical, so the angle has to be in between the sides. So if my angle is right here, the side's got to be over here because that angle's got to be in between them. Okay, if the angle is not in between, then it's not side angle side. Emily?
Could you name number 1 UVW is congruent to ZVX or not?
For the angles? Yes, but that wouldn't be your answer because that's your quote-unquote obvious. Because those angles are vertical. But yes, you could, yes.
When you said that, when you said the angle of the letter that's in between the sides,
The angle.
when you say that, like, what do you mean?
Like, notice how, hopefully I can draw here, yes. Notice how this angle is in between the sides. It's halfway, like, if I have this triangle, and I have that side, the angle must be here. The angle can't be here, because then my other side is down here. It's got to be in between, so it's got to be like it says, side, angle, side. So I can't have side, angle, or side, angle, and then the side down here. It's got to be, I really don't know another way to say it. It's got to be in between. Trying to figure out another way to say it. I'm just not sure. Other questions? I appreciate that y'all are asking questions. That's what I want.
Okay,
Go ahead.
so like number 3, how do you figure it is like the side and the side?
Okay. So, do you see that this is a side because of reflexive property? Let me explain it anyway. Okay, if I take these triangles and break them apart, so that's R, J, K, and this is J, K, I. Notice that side J, and I was told that R, K, and J are here. I was told, or we can see that side JK is with both of them, right? So a side that's the same is obviously congruent to itself, right? It's the same thing. So those have to be congruent to itself. And then I need the angle in between those two sides. Okay? So that's, I can't pick here because it's not in between. I can't pick here, it's not in between. So I would have to pick there and there. If I pick any other place, that angle is not in between the two sides. Does that help a little? Really don't know another way to word it. I'm trying. Yeah, Callie.
You can word it as the angle has to be made up of the two sides. Instead of in between.
There you go. Okay, that's a good idea. Yeah. So what Callie is saying is like, this angle is made up of those two sides. Okay, so it has to be made up of those two sides. So for example, if my angle is over here, so the red are my two sides, but if the angle is over here, then that angle is not in between. That angle forms those two sides, and that's not what I was asked about.
So with the second, like number 3 and number 2, like like they look the same.
Okay, for 2 and 3, you're asking for different things. Okay, so for 2, it's saying show they're congruent by side, side, side. 3 is saying show they're congruent by side, angle, side. So if it's side, 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 you just need to prove that 3 sides are congruent. If it's asking you to prove side, angle, side,
Okay, so
it's asking for 2 different things.
so if there is the side and the side is 3 letters.
It's always 3 letters.
So they say so there is the side, or is it side.
Mm-hmm.
Is that extra that is 2 letters? Like you see like.
Oh, just the way you're naming it. Yes, yes. Okay, any side of a triangle, just like with a line segment, any line segment of a triangle, or any line segment in general, you name with 2 letters. Any angle, you name with 3 letters. Okay, that's all that is. So if you're trying to name an angle, you use 3 letters. If you're trying to name a side, you use 2 letters. Any other questions? Okay, so let's keep going. Alright, so number 4, for 4 and 5, you just needed to list the congruent parts, okay? So that's what we talked about at the very beginning of the lesson on Friday. You have to use the name, okay? So for example, angle F, which is the first letter, is going to be congruent to the first letter in the second triangle, which is angle P. Angle G, second letter, is going to be congruent to angle R. And then H is congruent to Q. And then you can do the same thing with the sides. FG, that's your first two letters, that's congruent to the first two letters of the other one, PR, so on and so forth. And then the same thing for number 5. Are we okay with those at least? Can we do that? You just got to follow the order of the letters. That's it with that one. Just follow your order of your letters. Yes, ma'am.
When we have a test, who's going to use multiple choice?
I mean, it'll be majority multiple choice. You'll have a few short answer, but it'll be just like every other test. It'll be majority multiple choice. Don't worry about that right now. Don't worry about that right now. Oh, speaking of that, I guess we should worry about it right now. Raise your hand if you know you're not going to be here Friday.
I'm on field trip and I don't know what time.
You can. Okay. Test was tentatively Friday, but I might have to do it Thursday. I'll get back to you. Alright, are we good on 4 or 5? Just follow the order of the letters, that's it. Alright, now let's go in depth on these proofs. Oops. Okay, so for number 6, prove that the two triangles are congruent. Okay, so one thing I also want to emphasize is when you're doing your homework, take out your notes. Okay, I have to say this every semester. Have out your notes when you're doing your homework. Because your notes are there to help you. Your notes aren't there to just learn and then put away. Okay, they're there to help you along the way. Alright, so for number 6, you need to prove that the two triangles are congruent, and you're given that D is the midpoint of AB, and you're given that AC is congruent to BC. Okay, so first thing you need to do is list the givens. Alright, so one thing I should have written down that I didn't is that D is the midpoint. Okay, that would have been a given. And then I was also given that sides AC and BC are congruent to each other. That's a given. So if you can't do anything else in a proof, write down your givens. Because you'll at least get a point or two for that. Okay? Write down your givens. Literally just recopying down what was written. Okay? So from there, I can see that this side is congruent to itself by reflexive property. If I break these triangles apart, that's the same side. Okay, so that's going to be congruent to itself, and your reason for that is always reflexive. And then what we talked about on Friday is if I have a midpoint, that means it's cutting that segment in half. So that means that AD and BD have to be congruent to each other, because point D is cutting that line in half. And then from there, I've got 3 sides, so I can say that those are congruent by side, side, side. Are there any questions on number 6? So if you know there's a midpoint involved, you know that this segment or whatever is getting cut in half, which means the two halves have to be congruent to each other. Alright, for 7, we talked about this one really briefly on Friday. Remind me what bisect means? Splits in half. Okay, bisect means cuts in half. Right? So I'm given this. Gosh, I need to do a better job of writing out my givens. Alright, so I'm given that. And what we talked about on Friday really briefly is PQ and RX are bisecting each other. So that means they're cutting each other in half. So that means RT and ST are going to be congruent to each other. PT and QT are going to be congruent to each other because those segments are getting cut in half. Okay? And then, like I said, stuff's going to keep repeating. Okay? Now I've got intersecting lines. Those are vertical angles. So those are going to be congruent to each other. So I've got a side, an angle in the middle, and another side. So I can say those are congruent by side, angle, side. So like Callie was saying, I've got these two sides. That angle is being formed by those two sides. It cannot be any other angle. If it's any other angle, it's not side, angle, side. Okay. Questions on 7? Alright, and then I can't scroll down for 8, unfortunately. But, so, I was given that, let's see, QP is congruent to QS. So that's those two sides, and then I was given that the angles are congruent to each other. I know that that line segment PR is reflexive, because it's going to be congruent to itself. And then I could say those are congruent by side angle side. And remember so if you read the instructions, it's not asking you to prove the triangles are congruent, it's asking you to prove those segments are congruent. And we talked about that at the very end of class on a Friday. You have to prove the triangles are congruent first, but if the question's asking you about a piece of the triangle, then once you say that they're congruent by whatever, the two triangles, you can say that those parts are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So once you've proven that the triangles are congruent to each other, you can say that the corresponding sides are congruent to each other, or the corresponding angles, but you have to show that the triangles are congruent to each other first. Any questions at all? I appreciate y'all asking questions, but that's what I want. I want y'all to ask questions if you're not understanding. Yeah.
How come on 1 and 3 it's asking for the same thing but you named it differently? Like, number 1 is named by a line segment, and number 3 is named by an angle.
Because, okay, good question. So because, I don't know what it was. It depends on what your obvious is. Okay, so your obvious is not your answer. It's whatever the non-obvious is. So for number 1, my obvious is that those angles are congruent. So that means I'm missing a side, which is why I listed the side. For number 3, my quote-unquote obvious is that side is congruent to itself, which means I need the angle. So I'm still proving by side angle side, but my non-obvious is different. So for number 1, my non-obvious was a side. For number 3, my non-obvious is an angle. Any other questions? Alright. Then how about today's notes? Go ahead and pull those out. This will be on Schoology for you to look at. Okay? If you didn't do it for whatever reason, you can, if you show it to me by tomorrow, it's only 10% off, and then after that it's half credit. Okay, but since it's paper homework, you are eligible to turn it in late, unlike that. Okay, so just keep that in mind if for some reason you did not complete it. All right. Now let's go over today's lesson. So we are continuing on. So I mentioned on Friday that there are 5 triangle congruence theorems. So Friday we talked about 2 of them. Today we're going to talk about the other 3. Okay. The first one is angle side angle. Okay. So I need 2 angles and the side in between the 2 angles. Okay. So, and remember we called that the included. So this, in this case, would be the included side. So 2 angles and 1 triangle and the included side, so the side in between the 2 angles, are congruent to 2 angles in the included side of another triangle, then I can say the 2 triangles are congruent by angle, side, angle. So for side, angle, side, the angle must be in between the sides. For angle, side, angle, the side must be in between the angles. So for example, like if I, really quickly, don't draw this, but if I had, let's see, angle, angle, and I had that side is not in between those 2 angles. So just because I have 2 angles and a side doesn't mean it's angle, side, angle. Okay? Alright, so just like we did on Friday, let's go through and list the corresponding parts, and that way we can say these triangles are congruent. Okay? So which angle is congruent to angle M? S. Okay, tell me how you know that, Nate. The 1 arc, exactly. Got 1 arc involved. So that means those are congruent to each other. So M and S. So that's my angle. Okay? Be careful how you name your side. If I name that side as NN, what side is congruent to it? ST. Good, because I started with M, the 1 angle, so I need to start with the 1 angle over here, so that's ST. And then what angle is congruent to angle N? T, because that has 2 arcs. Okay? So if I name this first triangle M and L, how do I name the second triangle? To say those 2 triangles are congruent. STR, good. STR. And so those 2 triangles are congruent to each other by angle, side, angle. The side is in between the angles. Alright, the next one is angle side. Okay, so if I have two angles in the non-included side, so if I have two angles in a side, not in between the two angles, that's what angle side is. Two angles in the side, not in between the angles. So if I have two angles of one triangle in the non-included side are congruent to two angles in the non-included side of another triangle, then I can say the two triangles are congruent by angle side. Okay, so once again, let's go through and list off our corresponding pieces. What angle is congruent to angle U? X, good. Angle B? Y, good. And then, let's see how I want to name this. Let's name it VW. What side is congruent to VW? ZY or YZ? YZ, okay? I started off with the angle, so I need to start off with the angle over here. YZ.
How much slide picture about month this one?
Yes, okay. So, for angle side, the side can't be in between the angles. If it's in between, then it's angle side angle.
But like if it's on the other stuff.
You're talking about like over here?
Yes.
That's fine. Yeah, that's fine. Just as long as it's not in between. So it can be either side. Okay? So, let's see. I can say that triangle UVW is congruent to triangle, name it for me, XYZ. Good. Okay, so that's angle side. And the last one that we'll talk about is called hypotenuse leg. Okay? The really important thing about hypotenuse leg, it's got to be a right triangle. You cannot use hypotenuse leg for any other triangle because with right triangles, that's the only type of triangle that have a hypotenuse. Remember, your hypotenuse is the side that's across from the right angle. Okay? So you can only use hypotenuse leg. Highlight that, something, make a note, I don't care. You can only use hypotenuse leg if it's a right triangle. You cannot use it any other time. Okay? So if the hypotenuse, so remember, if I have a right triangle, this side is always your hypotenuse. It's whatever side is across from the right angle, if you need to make a note of that. Alright, so if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent by hypotenuse leg. Okay, so one more time, let's go through this. Side MN, what is it congruent to? PQ, okay, so I started with M, which is in between the two sides, so I need to start off with the angle that's in between the two sides here, so that would be PQ. Alright, the angle L is congruent to R, and then let's see, side LM is congruent to RP, good. Started off with the angle, so I need to start off with the angle here. So I could say that triangle, if I name it as MLN, how do I name the other one? PRQ, good. PRQ. So those two triangles are congruent to each other by hypotenuse leg. Alright, also notice, say this every semester, also notice that there is not a angle side-side triangle. Think about what that abbreviation would be. There's no such thing as an angle side-side. I'm not going to spell it out, but just keep that in mind. That's not a thing. Okay. Some of you are getting it, maybe not. Okay. You get it. If you don't get it, just keep that in mind. Okay, angle side-side is not a thing. So don't put that on your test, because it doesn't exist. Okay. So just like we did on the last lesson, we're going to to determine if these triangles are congruent by angle, side, angle, angle, side, hypotenuse, leg, or none. Okay? So, number 1. Angle, side, angle, side, hypotenuse, leg, or none. Angle, side, good. Okay, I have 2 angles and a side not in between. Okay, so since that side, first of all, it's the same side for both triangles, and it's not the side in between, I can say angle, side. Good. Alright, number 2. None, good. Okay, this would be none. Okay. This first one is angle, side, angle. But for the second one, that angle is not in between the 2 sides. Do you see that, Milo? How the angle here is not in between the 2 sides. So if it were angle, side, angle, I would need that angle right there. I need the angle that's formed by those 2 sides. So since that angle is not there, I can't say it's angle, side, angle. Okay? So because this one, first of all, the angle's not even the same for both of them. It's not that same angle. Okay, so because of that, I would say none. Go ahead. Are you saying, I'm trying to just understand your question. Are you saying, can I just move the angle? Are you saying draw what I just did? Like, draw that? Absolutely, do it. If that helps you. Absolutely, draw it. Yes, Molly.
So, okay, so like, so let's do something like, I'm talking about the one.
Okay.
So let's do, if it's like a leg, like a leg in the middle of it, and the little, it's called
Arcs.
yeah, the arcs. That it will be angle side.
It is angle, side here because the side, so if I draw if it were angle, side, angle, I would need the side right here. Whoops. So because I have 2 angles in the side, not in between those angles, that's why I can say it's angle, side. So I got 2 angles and a side not in between the angles. If it were in between the angles, so for example, if it were here, that side is in between the 2 angles, so it's got to be angle, side, angle. But because the side is not in between, it's angle, side. Other questions? All right. What would number 3 be? Okay, we'll get to it. Look at both triangles. They're 2 different, right? Okay. At first one I've got angle, side, angle. That second one I've got angle, side, right? So what would my answer be? None. Right? It's gotta be the same thing for both triangles. Okay, so this one would be none. It's gotta be the same. Alright, number 4. Before we do number 4, notice that I've only got a side and an angle. Is there something obvious here that I can mark as well? Yeah, this side, right? If I break those triangles apart, that's the same side for both triangles, right? So that would be your quote-unquote obvious. Okay? Because if I break these triangles apart, that's the exact same side for both of them. Okay? So what does that make this one? Hypotenuse, leg. Good. Hypotenuse, leg. Okay? Hypotenuse, hypotenuse, and that side we marked as a leg. Okay, so your legs are just any side that's not your hypotenuse. Okay, so that would be hypotenuse leg. Right? If these were not marked as right triangles, then I can't say that. Okay, so since it's marked as a right triangle, I can say it's hypotenuse leg. Emily.
I know that the middle is like obvious, but would it be wrong if you put one on each of the other sides, like, or wooden squares?
Like here? You would, so that would be like a question on your homework, like if you were given, let me redraw. So if you were given, it depends. Because then you could say side, 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 because you would have all three sides. Okay, so it's got to be a leg and a hypotenuse. Okay. So, if they were two separate triangles, so say I had two separate triangles, hypotenuse, hypotenuse, and then I said leg, that's fine. But that doesn't necessarily work here because that side matches. If I wasn't told that those sides matched and they were two separate triangles, then I could say that would be like my missing piece, would be those legs.
But even if you you left out the,
Okay. Alright, and then what does that make number 5? Angle, side, angle. Okay, that side is in between the angles. Okay, so that is angle, side, angle.
okay, so like, if it's in between like those arcs, angle, side, angle.
Yes. Okay, the same thing happens with side, angle, side. Okay, so if I have a triangle, that arc has got to be in between the two sides. If it's not, I'm glad things are finally clicking.
Okay, so what's the difference between angle, side, angle, and
Side, angle, side.
yes?
Okay, angle, side, angle, I have two angles and a side. Just think about the letters. Okay, and then for side, angle, side, I've got two sides and an angle. Okay, so just think about the letters. Okay, if I have two S's, that means I have two sides. If I have two A's, two angles. Okay, I'm glad things are clicking then. I knew they would eventually. This stuff is not easy, I promise. This stuff is not easy. Okay, I'm glad it clicked. I'm glad it clicked. Alright, any questions on 1 through 5? Alright. Here, okay, so these are like 1 through 3 on your homework last night, from Friday. Determine what additional information is needed, okay? When you're asked a question, determine what additional information, blah, blah, blah. You only need one thing. Okay? If it looks like more than one thing is missing, one of them is your quote-unquote obvious. Okay? So remember, you're looking for the non-obvious. Alright? So, let's talk about number 6. I want to show that these two triangles are congruent right angle, side, angle. Okay? So far, I've only got one angle, which means I'm missing a side, and I'm also missing another angle. So one of these has to be obvious. Okay? Is there anything obvious? Say it again, Nate. Yes. Okay. This side, TU and UT. It's the same for both triangles, right? Okay, so that is my quote-unquote obvious. Okay? So now, I've got an angle and a side, I need another angle. Okay? Be careful where this angle goes, because the side must be in between the angles. If it's not in between the angles, then it's not angle, side, angle. Where would these angles be? Okay, you're correct, but I can't just name it as T and U because, like, for example, U is this entire angle, whereas I don't need the entire angle. Say it. T-U-M. Yes. Okay, so T-U-M, I need that. So angle TUM TUV, yes, which would be this one. Angle TUV. So notice, so if I break these triangles apart, I have angle T, this side, and so if you ever need to, break apart the triangles and redraw it, okay? Do whatever works for you. Draw all over these triangles. I don't care. Do what makes sense to you. Okay, so I've got an angle, side in between, and an angle, so now I can say it's angle, side, angle. Okay. Number 7. I need this to be angle, angle, side. I've got an angle and a side, so that means I'm missing another angle, right? You can do that. Okay, you can do J and T. Actually, 2 answers for this one. Say it again. I and U. So you could, there would be 2 answers. J and T or, not and, okay, J and T or I and U. Because for angle, angle, side, I've only got one side. And as long as that side is not in between the angles, I'm fine. Alright. Number 8.
LJ per KA.
Repeat that, I'm sorry.
Line A and line KA is LJ.
How do you know that?
Because
Okay, so remember, there would have to be something glaring at me for me to tell me that that's the case. Okay? So, I have an angle. I need a, let's see, angle, angle, side. So I need another angle and I need a side. One of those has got to be obvious. KL and OK. Okay, that's my side. Alright? Because if I break these triangles apart, that is the same side. Okay, and any side that's the same on the other triangles converts to itself. Okay? So that's your obvious. Now I need an angle that's not in between that side. AJ. Okay, that's the only thing that'll work. If I do any other angle, that side's going to be in between. So that would be angle A and angle J. Just go class. What are you doing? What do you need? I'm teaching. What do you mean? What is it? Whatever. Alright, and then number 9. Hypotenuse leg. Okay, so I need these triangles to be congruent by hypotenuse leg. Something here is obvious, okay? Q and R, okay? Same thing for both triangles. Is that my hypotenuse or my leg? That's my leg. Okay, that's my leg. Remember, hypotenuse is across from the right angle. Okay, that's one hypotenuse. RX. And what? QP. There you go. RX and QP. So, hypotenuse leg, it's got to be your hypotenuse. Okay? Because this leg is the same leg for both triangles. So they're congruent to each other. Okay? Stay on to the front for just a second. Yes, Milo.
okay. How do you do like okay, so like what made you like say R8 and PP?
because that is my hypotenuse, okay? So, for hypotenuse leg, you need a hypotenuse and a leg. I said that I had this leg, which means now I need my hypotenuse, and my hypotenuse is always across from the right angle. So I have to have my hypotenuse and a leg. I have my leg, so I needed my hypotenuse, so I need the sides that are across from the right angle.
Oh,
Good question. Okay, are there any other questions before we move on to the proofs about anything on the front? Speak now or hold your peace. But I'm glad y'all are asking questions. Okay, that's what I want. Alright, let's flip to the back. Stop. No. Okay, number one, alright? Once again, just like I told y'all on Friday, I said, these proofs are a little confusing, so you need to be paying attention, okay? You don't need to fall asleep, you don't need to have your phone out, all that stuff, okay? Ask questions, alright? That's what this is for, ask questions. Because I understand that this is overwhelming and it's confusing, I get it, okay? But if you're not asking questions or not telling me what you're not understanding, then I'm assuming everything's fine and dandy, okay? But y'all have been doing good today with asking questions, so keep that up, okay? Especially with these proofs. Alright, number one. I need to prove that these two triangles are congruent. I'm given that PR is the angle bisector of angle QPS and QRS. Okay, we haven't talked about what an angle bisector is, but we can probably figure that out really easy just using some context clues. Remind me what bisect means. Splits in half. Right? Angle bisector is splitting an angle in half. Okay? So it is the angle bisector of QPS. Okay, so let's stop there. Angle bisector of QPS. Okay? That's got to mean that those two angles are congruent to each other. Okay? It's cutting it in half. So that means the two halves got to be congruent to each other. Okay, so it's the angle bisector of QPS. So that means those two angles are congruent. And QRS. So those got to be congruent to each other. Okay? Now now that we've talked about what an angle bisector is, what is the very first step in the proof? Write your givens. Okay? I was given that PR is the angle, abbreviate the best you can, bisector of angle QPS and QRS. And how do I know that? I was given that. The very first step. If you cannot do anything else in a proof, you can write your givens. Remember this stuff? I think this is the test you didn't do well on. Okay. So that's your first step. Write your givens. Alright. Now let's put the pieces together, okay? So we talked about this. Now we just need to put it into words, okay? So, let's see. Okay. Alright, if I name this angle QPR, so this angle right here, angle QPR, what angle is angle QPR congruent to? There you go, SPR. Okay, start with down here. I started with Q, I gotta start with S, okay? So that's congruent to SPR. And we'll say by definition of angle bisector. Because that's what essentially it is. By the definition of an angle bisector, those angles are congruent to each other. Alright, if at any point you lose me, please stop me and ask questions, okay? Don't hesitate. Alright? So I said QPR and SPR congruent to each other by definition of angle bisector. I can do the same thing for my other angles, right? So if I name this one as QRP, because remember the vertex has to be in the middle. Okay, so if I name that one as QRP, how do I name the other one? SRP. Okay. those angles are congruent by the exact same thing, definition of angle bisector. Alright, so I've got two angles. There's no such thing as angle, angle, angle. Okay, also keep that in mind, because on your delta, you have delta math for homework tonight, it will give you ones that you haven't seen before, like angle, side, side, angle, angle, angle. It'll try to trick you, okay? Just think about the five we've talked about. Angle, angle, angle is not a thing, okay? Alright, so that means I need a side, okay? Does the problem, like, does my given tell me anything about a side? No. Okay, so something has got to be obvious here. PR, okay? Look at both of these triangles. They both share PR, right? Okay, so side PR is congruent to PR, and what's my reason? Reflexive property, very good. Anytime something's congruent to itself, reflexive property. Okay, reflexive property, very good. So how are these triangles congruent? Angle, angle, side, or angle, side, angle? Let's see. Angle, side, angle. Okay, the side is in, let's see. The side is in between the angles. Very good. Okay, so finally, I can finish this thing off. Triangle RPQ is congruent to triangle RPS. Side, angle, side, angle. Good. You cannot get this on your Alright, are there any questions on that proof? Read over it real fast, make sure there's nothing that doesn't make sense. Yes, Ellen?
Can you just draw it split in half?
Yes, I can. Okay, so this would be, yeah, if you need to split it up yourself, by all means, please. So this is QPR, and this is RPS.
All of the angles and stuff on the top line.
So you have one here, yes, here, here, oh, that's your stuff. Okay, so split it up if you need to be able to see all this, okay? Like I said, do it on the worksheet. Draw, let's, I don't care. Whatever is going to make it work for you. Alright? Let's do number 2. Alright, prove that these triangles are congruent. I'm given that angle V. So remember also, draw whatever you're given on your triangle. Okay, so I'm given that angles V and U are congruent to each other. Arc. Okay, those angles are the same. They're congruent to each other. I am also given that EF, so segment EF, is perpendicular to VU. Okay, what does that mean about where they intersect? Right angle. Okay, so that means that that's the right angle. Okay. Alright, now let's, first things first, write out your givens. Okay, so I was given that angle B is congruent to angle U. Given, I was given that EF is, remember perpendicular, the, let's see, upside down T. So EF is perpendicular to VU, given. Let's see. Alright. So that's my givens. Okay. If I name this first angle, let's talk about it. Okay, so it's not necessarily a given that I saw that was 90 degrees. Okay, I do have to write out some sort of reasons. Okay, I was only given that those two are perpendicular to each other. Okay, so if I name this first one as EFV, how do I name the second angle? EFU. Okay, and I'm just going to say that those are congruent to each other by definition of perpendicular. By the definition of perpendicular, those are going to be 90-degree angles. Yes, Jackson?
Is there ever going to be like a question where like it gives us like our proofs and we have to give it like the reason, and we have to find reasons?
So I believe, oh, I'm so worried about this test. On your test, I don't remember if it, there may be one you have to do from scratch, but I think a lot of the questions like kind of help you along the way. Like, it may give you this, you have to give the reason, or vice versa. It gives you this, you have to tell me this. Okay, so it goes back and forth. But I think with most of the questions, the proof sort of helps you along the way. So you don't have to do the entire proof on your own, but it gives you pieces that you have to figure out, okay? Don't worry about the test right now. Okay? Just for you. You're going to be okay. Alright. Let's keep going then. Okay, so that talks about my angles. So I have two angles. Now I need a side. Does the example, or not the example, does the given tell me anything about a side? No. Okay, so something has got to be obvious. There you go, EF. EF's congruent to itself, right? Same thing for both triangles. So, there you go. So side EF is congruent to side EF by reflexive. Okay, so this is a really good example of just because this thing is a right triangle does not mean it's a hypotenuse plane. Okay? There's nothing in this example telling me anything. So like these sides right here, EV and EU, those would be my hypotenuse. There's nothing in this problem telling me that those are congruent. Okay? So I would either have to be told that or there would have to be something really obvious. And there's just nothing obvious here. So this is a really good example is if you can have a right triangle and it not be hypotenuse-like. Okay? Alright. Am I done? Or almost? Have I listed everything? Angle, angle, side? Or whatever this is, angle, side, angle, whichever one. Emily, what do you think? Okay, good. Alright, so now that here comes the question. Are they congruent by angle, angle, side, or angle, side, angle? Which one? Okay, is the side in between the two angles? No. Okay, my side is over here, my angles are down here. Okay? So when you have two angles on a side and the side is not in between, that is angle side. So EVF is congruent to EUF by angle side. Any questions on number 2? Look at it for a sec, read over it, make sure there's nothing you're not misunderstanding. Alright, so let's do number 3. Alright. What do you notice about what this is asking you? Prove, it's not saying prove the triangles are congruent, right? Unlike the other two problems. So when it says something other than the triangles, what do I have to have at the end of my proof? CPCTC, yes, okay? So at some point, you still have to prove the triangles are congruent in order to say that, okay? So if your statement ever says prove, so notice for the other two, prove that the two triangles are congruent. Prove the two triangles are congruent. Prove two sides are congruent, okay? So you have to prove the triangles are congruent first, but then your final statement has to be that CPCTC, okay? So just keep that in mind. That's going to be a trend. If you ever see that the triangle or the proof doesn't necessarily say prove the triangles are congruent, it's just asking about two sides, you've got to do CPCTC. Alright, I am given that angles A and C are congruent to each other, and I am also given that BX and DX are congruent to each other. First step, write out your givens. Okay? So A is congruent to C, given. And BX is congruent to DX. Given. Like I said, if you can't do anything else, can't figure anything out, write that out. You can at least do that. Alright. That's all I've got. Anything else I can figure out? Because, there you go. Okay. Intersecting lines, opposite angles. Those are going to be congruent to each other. So angle BXC is congruent to DXA because they're vertical. Good. As you can tell, vertical comes up a lot. Angle or bisector, whatever. If it's perpendicular bisector or angle bisector, that comes up a lot. This one comes up a lot. Okay. All right. So I've got an angle, I've got a side, I've got another angle. How are these triangles congruent? Angle side angle or angle angle side? Angle angle side. Good. That side is not in between the angles. If it were angle side angle, that would mean that sides AX and CX got to be congruent, but they're not. Okay? So I can say, let's see, triangle AXD is congruent to CXD by angle angle side. And now that I've said that, are AX and CX corresponding parts? Are they in the same position on the triangles? Yes? Okay. So now that I've said that the triangles are congruent, the corresponding parts have to be congruent as well. So I can say AX is congruent to CX by your CPCTC, and now you're done. So once you've proven that the triangles are congruent, you can use your CPCTC. Corresponding parts of congruent triangles are congruent. Questions on number 3. 2 more problems. Alright. Number 4. Prove that these two triangles are congruent. I'm given that AD bisects angle A. What does bisect mean? Split in half, cut in half, whatever. Okay, so that's my given. AD bisects angle A. So what does that mean about, how do I name this? Angle CAD and BAD. They're congruent, okay? A is splitting, or AD is splitting all of angle A in half. So that means those two pieces have got to be congruent to each other, because they're the halves of angle A. Okay, so CAD is congruent to BAD by definition of bisector. Alright, Bryson,
BDA be congruent to CDA,
tell me why, yeah.
vertical.
Not vertical.
Horizontal.
You're correct that they're congruent. So Bryson is saying BDA and CDA. Not reflexive. Okay, we weren't told it was a perpendicular bisector. What is this right here? Supplementary, okay, it's just a line. Okay. It's probably a perpendicular bisector, but I wasn't specifically told it was, so I can't say this. Okay. But I have a line. So if this is 90, then that's got to be 90. Okay. So I can say angle BDA is congruent to CDA, and I can just say supplementary. Alright. So I've got two angles. Not given.
How much,
There you go. Okay. AD is congruent to itself, right? It's the same part of both triangles. Okay? So AD is going to be congruent to itself by reflexive. Angle, angle, hypotenuse leg, side, angle. Good, I've got an angle, side in between, and another angle. So, I can finally say triangle ADB is congruent to triangle ADC by angle, side, angle. Okay. Alright, one more problem, then we'll be done. Alright, number 5. Prove that these two triangles are congruent. Okay, I'm given that QP and QS are congruent. So I'm going to start off with that. QP is congruent to QS, or PR, I'm sorry. PQ and PR are congruent. And PR is perpendicular to QS. That's also given. For the perpendicular? Oh, yes, you're correct, I'm sorry. PQ and PS, yes. Yes, thank you. PQ and PS, I apologize. Alright. What else can I figure out from here? PR is congruent to itself, right? Good. So by reflexive. Am I done? Repeat that, I'm sorry. How do you know that? Q and S. Alright. Not seeing anything here that can tell me about those being congruent. I don't see anything. They're not vertical, and I wasn't specifically told that they're Hypotenuse leg. Okay, we're done. Okay, I've got my hypotenuse. So the sides opposite the right angle. And I've got a leg. Okay, that's it. Alright, right triangle, got a hypotenuse, I got a leg. Yeah.
What if that's like when we combine like all 5 of them? How would you know if it was side, angle, side? Like,
Okay, if this were side angle side, then it would be, you would need this side. But I don't have that. I've got a leg and another side that's not in between. And then because they're right triangles, that makes it hypotenuse leg. Okay. So, last thing. PQR is congruent to PSR by, let's see, hypotenuse leg. And questions, comments, concerns? I know there was a lot. I think I'll be sure to for sure tell you tomorrow, but I think I had another lesson we were gonna do, but I think I'm just gonna skip it. So I think tomorrow will be a practice day, and then Wednesday we'll review, Thursday we'll test. And then Friday will just kind of be like a makeup day. So like if you're missing a test, Friday would be a good day to make that up. When you're missing homework, things like that. I can't say that's how it is going to be for all your classes. So if you have a test on Friday and they are sorry, gotta be here. But I'll for sure tell you tomorrow. But just based on how we're progressing, I think it's best to skip that test. Alright, let me show you something on your homework that it's a little confusing to start off with, but once I show it to you, it'll make sense. I do not yet. So we're gonna do, this probably won't take all of class. So what you're gonna do tomorrow is, you're not practicing proofs necessarily, it's like a cut and paste activity, figuring out, like if you have 2 triangles, looking at them, deciding how they're congruent, and then you'll cut and paste them. And then what I think I may do after that is either let you work on Delta Math, or if you would like some additional problems, I can give them to you. So tomorrow's going to be kind of chill. Tomorrow is also Tuesday, 2/2/2/2/2. So I may have like a fun bell ringer or something, just something light to get us started, and then just nothing too crazy. Are y'all going to the game? Oh, okay. Okay. Let me remind me once I'm done talking about this, and I'll get it to you. Okay. Delta, maybe. Let me log in. Good. Hold on just a sec. Okay, good. Alright, so on your homework, there we go. Okay. Edit assignment. This one. Okay. Alright, so triangle congruence basic flowchart, okay? So first thing it's going to ask you is, are the triangles congruent or not? Okay, so looking at this picture, using one of these 5 theorems that we've talked about, does it look like these triangles are congruent by one of these? Which one? Angle, side, angle. Okay, so you would say the triangles are congruent, and then it kind of gives you this flow chart, okay? So everything's already marked for you, so essentially for this proof, everything's given. Okay, from here, you list everything off, okay? So it depends. Let's just start off with an angle. So you'll click the angle symbol, and which angles are congruent to each other? Pick N and Z. Okay, N and Z are congruent. Alright, let's talk about the other angle. What other angles are congruent? L and B. And then what side's congruent? Yeah, ZB. So ZB and an L. And then you would say these triangles are congruent. How are they congruent? Angle, side, angle. Okay, so that's how you do that. Okay, so if you're talking about an angle, click the angle button. If you're talking about a side, click on the side button. Okay. All right. If you want to start your homework, you can. We don't have that much time left, so I'm not going to require you to per se, but I think it would be good to at least start. And then tomorrow, we're just going to do a good bit of practice. Okay. Trying to think of what. Because obviously you're not going to want to cut some really fast. Maybe I'll go ahead and give it to you because obviously tomorrow y'all will be doing it. I'm assuming you have. You're not going to mind.